Manufacturing Association. I would like to welcome all of you to this webinar by ICMA's MTech on driving innovations in the plastic industry with 3D printing. The 3D printing applications are now becoming more and more used or popular in the industry, especially for our prototyping needs. They provide solutions that can really streamline workflow to accelerate our digital design, create appearance models, and build functional prototypes. Also in production, additive manufacturing is now being used for short batches, and which is now actually a reality, with productivity, durability, repeatability, and also total low cost of operations that the manufacturing industry require. These are also being used for jigs and fixtures. So the very objective of organizing this webinar was to bring the insight on the real 3D technologies which could be used by the plastic industry specifically. We have seen a lot of webinars being organized on this technology, but we wanted to basically specifically discuss its application for the plastic industry. I'm very thankful to Stratetis for becoming a partner for this particular webinar. We have been talking to their officials, Mr. Rajiv Bajaj specifically, who is heading India operations, Shrikant, and the entire team member. We are very thankful. We welcome our guests, speakers, Mr. Fred, and also Mr. Satish to this webinar. Again, welcome everyone. We'll start with a welcome address by Mr. Kishore Sampath. He is the President of All India Plastics Manufacturing Association. He has been the Managing Committee member of ICMA since 15 years. He's a very successful businessman, owns a very old 5-decade-old company. They are into basically manufacturing of compostable polybags and recycling. His company's name is Polygen Industries. He has been the founder of ICMA's Job Fair, which is one of the very important and very successful vertical of ICMA, which has given jobs to thousands of students. Very active, very vibrant, very energetic. I would request our Kishore Bhai to give his welcome address.
Audible?
Yes, please.
Thank you very much for your kind words, Mr. Balani. On behalf of All India Plastic Manufacturers Association and our team, we welcome the speakers, Mr. Satish Kumar and Mr. Fred Fisher from Hong Kong. We are very, very fortunate to have them. They are the champions in their area, and Stratetis is a leader in the 3D printing equipment. So we welcome them. And 3D printing is the technology of the future. With the personalization taste of the consumer, 3D printing is the correct answer to address that need of the consumers today. So we welcome, and there is immense opportunity and potential. I'm sure our delegates will get a lot of knowledge, and it is very informative. So we welcome you all, wishing you all a very nice event for us to gain knowledge. Thank you also. All yours, Balani ji.
Thank you, President, for your welcome address. I would now like to introduce Mr. Arvind Mehta. He's the chairman of ICMA's Governing Council. He is also the chairman of ICMA's MTech, the Center of Excellence for Plastic Product Innovation and Application. Arvind Bhai is also the chairman of National Advisory Board of Plastic Vision India 2023. Almost the entire industry knows him very well. Arvind Bhai has been the president of ICMA, also Plast India Foundation. He has also represented SciPad on behalf of Asia. He is also the managing director of Wellset Plast Extrusion, one of the leading manufacturers and exporters of master batches. Arvind Bhai, as everyone knows, is very widely recognized and respected by the entire plastic industry for his tireless and valuable contribution in the last 30 to 40 years. Visionary in thoughts, visionary in dedication towards growth of the plastic industry. I would request Arvind Bhai for his address, please. Arvind Bhai.
You are able to hear?
Yes, please go ahead, Arvind Bhai.
So,
Yes, Arvind Bhai. Arvind, we can't hear you, Arvind Bhai.
these things. I think Deepak, you continue for the next. There is some technical issue.
Okay, sir. Okay, sure.
Yep.
So we will maybe Arvind Bhai is facing some technical issue, but I will just try to briefly take one more minute. This webinar is being organized by IPMA's AmTech. AmTech is basically Arvind Mehta Technology and Entrepreneurship Center. It's a center of excellence for plastic product innovation and application. The very objective behind setting up this center is to help the plastic industry in exponential growth. It is the center which has been established so that the center can give services to the industry so that their products can be manufactured, designed faster. The entire turnaround time could be reduced. So we have various verticals. The center is working on reverse engineering with Zeiss. We have been working on product design with Autodesk and Siemens. With 3D printing is one of the very important components in this entire ecosystem if a unit wants to manufacture products faster. So we are very thankful to our friends who have been providing the knowledge in the domain of 3D printing. Then we are also focusing on plastic packaging and managing programs. So this program has already generated a lot of traction in the industry. We have held various programs in last 6 to 8 months. Almost 300 to 400 industries have already benefited from the center. So we will also put our website address and the details on the chat box. So if you need to know more about the center, you're most welcome. So we now move ahead and introduce to you our moderator of the day, Mr. Paresh Bheda. He is the director at Protosys Technologies Private Limited. They offer end-to-end services in design, prototyping, mold manufacturing. He is our managing committee member of IPMA, and he's also a member of our technical committee of IPMA's AmTech. He has more than 25 years of experience in additive manufacturing and has been associated with many new product development companies. He has worked with companies like HUL, Marico, Tata Motors, Philips, Siemens, and many more. So I would request our Paresh Bhai Bheda to moderate this session and take this forward, please.
Thank you, Deepak ji, for your words. I would like to introduce our first speaker of the day, Mr. Satish Kumar. Satish Kumar is the Senior Application Specialist for Stratasys India and ACA. He has more than 15 years experience and specialized in product optimization, lightweight design, and additive manufacturing. Prior to Stratasys, he has worked with John Deere as an enterprise core technical team member for lightweight materials and additive manufacturing. He received multiple awards, which includes Enterprise Innovation Award and Apex Award for India Innovation for his contribution towards intellectual property and ICME approach for cost reduction projects. He has 6 invention disclosures, 3 patent filed and 2 patent granted. I invite Mr. Satish to take over. Thank you.
Thank you, Mr. Paresh ji. I'm not getting an option for share content. Can someone please give me an authorization? Thank you. Okay, so welcoming, thanks for everyone for joining this session. So let me start share my screen. Just to avoid any kind of a buffering, I will put my video on off mode. Later on, I will resume that. Okay, so good afternoon, everyone. So I'm Satish. I'm going to talk about how this, especially in the way of innovation happening, using this 3D printing technology, we can able to drive more focus towards the manufacturing sector. So today I will be talking about the content about what are there are 3D printing technologies, and many there are, as we can look into that, there are a lot of 3D printing technologies available. So I will go in depth of what is this, each technology will help you about it. And with respect to those in the application side, how people can able to take it forward from each applications, and what are right now developments happening overall in the 3D printing industry from advanced side of materials, and how people right now start using those advanced materials in the way they're developing their process and technologies, everything into the way. So starting with this one in 3D printing or additive manufacturing. So first of all, what is this actually? So this is actually a process of joining materials in order to make an object. So this was a definition given by ASTM, American Society of Testing and Materials. And they also recognized this is a process for taking to make it as one of the manufacturing process. That is why this 3D printing turns into additive manufacturing. So for any 3D printing process, the first and foremost is actually we need to have some kind of a CAD model. So either this CAD model, we will get it from a CAD software or through kind of an scanned data. And these data generally people will go in the way of STL, standard tessellation language. They will make in the form of a mesh file. And these data will be given to a software. That software used to do a slicing. How in a CNC machine we make a G code, like that any 3D printing software, they make this kind of a STL slicing. So that will make slice by each layer by layer process. So these process will be given to feed into a machine where it will actually make print layer by layer, layer by layer. That is how the entire 3D printing an object is created using this additive manufacturing process. Now, why people want to go for this kind of 3D printer? So most of them will first of all focus for this 4C. So first C is actually called compression of time. Because right now in the day-to-day of every manufacturing, time plays a very major role. And everybody want to be an agile and they want to make their product innovation more faster, everything into that one. So that is why 3D printing really helps them that they can cut off their time. If we compare with most of the traditional process, you can squeeze the time close to 60% of the time you can able to close it to that one. And the next important activity is creativity. And sometimes there are complexity involved in the way of a product design and people want to go in the part of manufacturing. So here actually we can able to overcome all the level of complexity and we can able to do our creative innovation in the way of printing, because 3D printer don't rely with respect to the traditional manufacturing process. As it works on layer by layer manufacturing, the complexity comes up free for you. And next very important C is actually cost, because cost plays a very major role in any kind of manufacturing process. Because especially when you determine how the product is going to work or how the tooling is going to work for your requirement, everybody want kind of a time consumption and also they want to play kind of a cost benefit requirement into that one. So that is why 3D printers really help them in making with respect to get as end product requirement at the very early stage with kind of an almost 50 to 60% of cost saving at the time. And foremost important, right now, people protecting their IP, intellectual property, so confidentiality. So any design which respect even in the part of a mold design, even in the part of kind of thermoforming, many kind of a process, how we are maintaining the way of a process innovation. If you take it from product design, it is kind of a design. If you take it from the manufacturing, how we take consideration for requirement of each of the process, how we design our gating. So everywhere that kind of fun process innovation we need to protect it. That is the reason they want to develop in-house everything into that one. So here, this 4Cs, this is what actually right now 3D printer really helps them in most of the product requirements. Now, what are these industries actually using this AM? AM means a short form of additive manufacturing. So what are the industries? So if we can start from every industries, from aerospace, automotive, medical, transportation, even we can go into kind of an oil, gas, energy, heavy industries. Everywhere right now they start using 3D printing. The main important reason is because of the way it is flexible for their requirement in the part of their process. And also it helps them in their entire product life cycle, because people start from initial design and people want to move from design to engineering. So they want to fine tune from engineering. They want to work out on the manufacturing aids, tooling, jigs, fixtures. Now they want to go for some alpha production and beta production, some very low volume production. In entire product life cycle right now, this 3D printing is helping. That is how we also have many different technologies to help them in the way of each of the process, starting from that one. So for focusing on design segment, there are technologies called jetting and SLA. So these are the terms used by ASTM. If I mention about extrusion technology, these are under extrusion technology. We have each of the process. These are defined by ASTM. So let us come to a conclusion. Okay, how we this technology to be used, or what are these technologies, or what I should focus for that one. So based on this chart, if based on your quantity, whether you have a low quantity or kind of high quantity, whether your focus is on aesthetic or if your focus is on mechanical requirements, we can categorize this one. So that if you want an extremely low quantity, you can focus on jetting technology or FDM technology. So these two things comes under it. Jetting means Polyget technology, FDM means fused deposition modeling technology. Now, if you want kind of an extremely high level of quantity you want to go and you want to focus on mechanical requirements, we have a technology called powder bed fusion. Now in the powder bed fusion, people uses with a laser source, people uses with a binding technology. So here you can able to speed up the process more than generic other technology into that one. Okay. Now I will classify each of the technology, how it works and where we can able to put focus on that one. The first technology is called FDM technology. FDM means fused deposition modeling. And this technology was invented 30 years ago by a gentleman called Scott Cram. And he's the founder of Stratasys, and he's the one who invented this FDM technology. And this technology works similar like many of the people, how you can able to come from injection mold background. So this technology works similar from a thermoplastic material. Here, instead of thermoplastic, people used to from an injection mold, people used to take it from pellets. Here, this thermoplastic material will be in the form of wire. As you can see from the animation, these wire will be taken to a heater unit. And this heater unit actually melt the plastic filament and extrude on the tray to build the pattern layer by layer from the top and bottom up. That is the reason we can able to get this entire object made out of this one. And if you see this one, this technology actually will be make most accurate and kind of an extremely durable parts of everything into that one. So that's the reason this particular FDM technology is most of the people preferred for making using for prototyping and tooling and also for kind of an end application. When I'm saying end application, there are people from aerospace industries, there are people from medical industries. They want to use some of the certified grade material and also some of the FST requirement material. So FST means flame, smoke, and toxic resistance. So these are some of the classified materials and certified materials to be used for a very, very specified purpose on that one. And we can able to customize all these things based on all the range of material product portfolio, using from your standard materials to your high performance material. Now, what are those materials? So whatever we are using your generic plastics from your ABS family or ASA family, this comes under your standard plastics. Now going to the next level, things called engineering requirement called nylon, polycarbonate, and polycarbonate based ABS material. This comes under engineering plastics. Going to a high performance polyetherapide, polyether ketone, where people want to work on some of the area where high chemical resistance for most of the mechanical properties. Now take that kind of a material called nylon poly CF. So CF means carbon fiber. So in the material along with nylon, carbon particles, 35% of carbon particles added into the one. It acts kind of an excellent properties, especially in the way resistance for kind of stiffener, because directly people can replace from, because everybody right now working on lightweighting application in most of the requirements. So people can directly take these materials for their requirements in replacement for steel or even from your aluminum application. You can use these materials. Some generic requirements where I can use, because there are so much of material and it make me confusion where I can use it. Easy categorization. Most of your fit form function application for all your limited level of automotive testing parts, everything you can use with a standard and engineering material like nylon and ABS, everything into that one. Wherever you want to have kind of an excellent strength, you want a superior material where it needs to kind of a highest temperature, something close to 220 degrees Celsius, and you want some food grade material, and you want to use some biocompatible specific material, and you also want to use ESD, electrostatic dissipative material, and some specific application for space application. In this area, you can focus for those kind of high performance materials, simplified the process. Okay, what kind of parts I can able to use from this technology? You can take a parts from as smaller size and also to a kind of a bigger parts, actually as big to kind of a car bumper, also to a truck bumper. You can able to make it one, because these machines are made in such a way like that. Use it for all durable applications. You can use it for not only just limited to prototype. You can use it for even end application. A summary quick thing: FDM, easy to use with kind of an all thermoplastic material. You can use it from standard engineering and high performance. You can use it from prototype to tooling application. When I'm saying tooling specifically, you can use it on kind of a metal forming. You can also use it for a fit form function. You can also take these for composite layer tooling, and like end products, like some of those things directly, you can use it for aerospace, everything requirement. You can use this technology. The next technology I'm going to talk about is called Polyget technology. So this comes under, as per ASTM, this comes under jetting. So previously FDM comes under extrusion technology. This comes under jetting technology. So this technology, I would say, is a very powerful 3D printing technology. The most recent, it creates a very beautiful, smooth and accurate parts. And this technology works similar like your inkjet printer, but instead of ink, it actually deposits an photopolymer material. These photopolymer materials can be easily curable by the UV lights. So that is the reason, if you can see from the animation, these parts will be cured immediately in the machine itself. So you can able to get almost 640,000 colors. You will get that one. And not only just colors, you will get kind of a full transparent material. You will get opaque material. You will get multi-shore, from shore 30 to shore 95. You can vary all the level of rubber shore thickness. You can play around that one. And whatever the image you see on my right side, everything is actually made from this 3D printing technology. Like you can make colors, you can make wood texture, everything. And just to give some other example how this works, so whatever the parts you are seeing, these are 3D printed parts came out from the technology. You can see from that one the shape of the bottle, like you can able to make a fit form, and also you can evaluate the colors. So this technology will help you even to take it like some of the Pantone color shades, because right now everybody is moving towards in the way of product innovation. You can also take those colors in the part of your product design and get very early stage of prototyping and evaluate it. Is it only limited to that one? No, there are some things you can able to work similar like leather kind of a material, but it is not actual leather, but it mimics leather like a texture. It mimics like a wood like a texture, gives everything. And these are complete plastics only. These are purely from the polymer only, but it mimics like wood kind of an appearance for everything, so that you will get kind of a fantastic CMF, actually many industrial design people call color, material and finish. You will get this at the very early stage from this technology. Okay, what is for manufacturing people about this technology? You can also make a mold out of it. Because this technology, there are some of the engineering materials you can also make molding. So these molds people can use it for kind of an applications like for injection and also for blow molding, which I will cover in the more detail in the way of my application slide. The next technology I'm going to talk about is called stereolithography. So stereolithography is a very, very well-known technology available in the market actually. So how this technology works actually? So this technology actually uses a kind of a vat of liquid UV curable material, and this is also photopolymer material. So here this UV or laser light actually passes on the kind of each layer and cures that at a time. So that is the reason you can able to create a very kind of a beautiful shape parts out of from this part from the machine. And here you can able to get as much as detail also as possible from this technology. And very good for you can able to make kind of a bigger size, large size of a prototype. For manufacturing people, what they can do, you can able to create a pattern out of it. So using this pattern, people can able to make silicon molding. You will get kind of a very clean shape out of it. And there are a lot of applications. You can also do some of the injection molding. There are also you can able to make some Jigsaw fixtures out of it actually. And there are also parts you can able to make it for some of the end product. But primarily this technology people use it for making mostly in the form of pattern making and also for a very clean surface wherever people want to get that. And this technology primarily helps them to that one. Now I shown you FDM technology, Polygen technology and stereolithography technology. The next two technology I'm going to talk about is called actually towards the production side. So the technology name is called the SAF. SAF means Selective Absorption Fusion actually. So this technology actually you can see from the image, it uses kind of a powder material in the form. So these powders are polyamide. So polyamide, nothing but nylon. So it uses a nylon powder for most of this application. So how this technology works, if you see from that one. So these are print head based kind of a powder bed fusion actually. So here, if you look into this one, the powders will be generally deposited throughout that inside area, and there will be a binding mechanism. So this will be deposited in the layer, each layer, and there will be a fusion agent which passes immediately when that is happening into that one. So what advantage for the people when working on this soft technology? You will get an engineering material like nylon kind of a parts, and also you can able to make it for your extremely low volume production parts. It is extremely, you can able to take it for all mechanical strength application. This technology really works very well for them. Okay, is it limited only for small parts? No, you can also take it some of the parts for taking for some of the snap fit application, and also you can able to take it for a mass customization requirement right now, because this is becoming right now more famous in that way. People are start making into that one. This fits for most of the applications people want to do that one. The fifth technology I'm going to talk about, it is called P3 technology. P3 means programmable photo polymerization. This is an advanced version of DLP, digital light processing. So how stereolithography works, similar kind of mechanism, but instead of that laser light, actually the entire light will be actually make that area totally curable. So what is an advantage for people working on DLP process? So DLP process is actually a very, very high throughput process. So here people can able to get extremely fine detail of the parts taken out from DLP machine. And these people can able to right now, what are the limitation of stereolithography? You can able to go for the extreme range of high performance materials. So when I'm talking about high performance materials, people can take it for a level. They can customize their material in such a way it can able to work for an extreme high temperature and also suitable for kind of a high impact load kind of a material properties. So you can work out on that one. And very important, right now there are extremely a challenge in getting as best kind of an injection mold quality in any 3D printing process. So this P3 technology is designed in such a way like that you will get even close to 50 micron kind of details you can able to get from that one. So that means actually it is as best kind of an injection mold surface finish you will get directly from that one. And as mentioning in the way from the part of high performance materials, everything into that one, you can also take these material customization for this technology where you can take it for kind of a very, very extreme high temperature where people really specifically want to use it for FST, which I already told in my first start of the slide, flame, smoke, and toxic resistance, and also for specifically for high extent temperature, everything. So these are specific requirement for most of the aerospace and defense requirement. So here you can open with these kind of a technology to do that one. And also you can use it with many of the mountings, connectors, brackets, everything, all detailed parts. Whatever you want to take it an immediate prototype looking for from injection mold quality with very minimal parts. If you want to look into that one, this technology really helps. One. Okay. I've talked about right now all the technologies like from FDM, Polyget, stereolithography, SAF, SAF technology, and the P3 technology. Now, what these technology actually people use it in applications. So like I mentioned, people start using for prototyping, and now people want to move towards the next stage from tooling and also end use parts. So tooling for people from the manufacturing, because this is mainly for manufacturing forum. So what is useful for you, the manufacturing? So people can use it for your fixtures, people can use it for your mold, people can use it for your silicon molding, injection molding, even blow molding. A lot of things you can able to use into that one. How? If right now still lot of 3D printing applications, people start primarily using this one and only focused for prototyping. Still the blue ocean is we call the digital manufacturing. The silicon molding, blow molding, injection molding, most of them still not really exploring those capabilities into the way. So I will going to talk about few of them actually in my next slide actually. So also I'll talk about one more parts called carbon fiber. Now still people really want to make lot of cost reduction parts actually in the way converting from metal application to lightweight application. So carbon fiber is a best fit for people who want to make such kind of a part in a customized way using that one. So here you will get best of its part in the strength, and also you can able to get lightweighting. Like taking an example, a lot of them, even many of them asking about right now, looking in India as manufacturing things, EV and drone growing a lot of stage into that one. So especially lightweight plays a very important role for increasing their payload capacity, also increasing the battery performance, everything. So carbon fiber you can able to consider in adapting in that way. So now there are many ways instead of going for traditional process, 3D printing help them in simplifying this carbon fiber. Like you can able to work on the layer tool, sacrificial tool. So you don't need to spend a lot of money in making kind of a mold. So simplified 3D printing will help you develop such kind of lightweight parts. So going into Jigsaw Fixture application, how this helps actually, you can see from that one. So people can able to work out on a lot of such kind of Jigsaw fixtures in manufacturing. In manufacturing, even people consider these scratch areas with kind of multi-material process. You can use these different 3D printing technology. So you can also insert your part number wherever you have some scratch resistance area. This rubber material will help you in preventing those scratches directly, everything into that one. And talking specifically on silicon molding, like stereolithography or Polyget kind of a technology, which helps you create very beautiful parts. You can use those parts as a master, and using silicon as a mold, you can able to develop some limited number of parts, less than 100, less than 500, based on complexity, so that your silicon mold, you can reuse it for those many applications. And again, if you want, again with the same pattern, you can work out on that one. This is the very, very easiest way in creating the proto parts, everything into that one. And blow molding. Now going in the shape, especially in the hollow shape, people want to work out on some customized way into that one. You can skip sometimes for the low volume parts. You can able to, instead of avoiding the CNC, you can able to try this Polyget molding. So I will play a video in which you can see about two processes. One is extrusion injection molding, and also from injection molding directly into that one. So in this video, whatever you see as a green color, these green color parts are actually made as a 3D printed mold. So this is to make a bottle part actually, you can see that one. Now there is an extrusion happening on that material. Now there is a blowing happening on that one. You can see that one actually easily the parts came out from the technology. So this sometimes what happens, there are a lot of things people want to try out in the way of prototyping. So here 3D printing really helps them more, how they can able to make these low volume parts, and these parts are not made for a replacement for your steel molding. So here sometimes you want to make very, very low volume parts. You feel there are a lot of things you want to do some things in the kind of a product iteration. So this technology will help you in making kind of an squeezing your time by almost 60%. It will help you in squeezing the time into that one. So it's a very, very major benefit for most of them, because when you want to bring your product to the market, it really helps them a lot. And similarly, in the another one, actually, you can see one blow molding application. And similarly, you can use it for kind of an injection molding process also. So this is one of the recent thing actually, people, a lot of them trying in the way of footwear mold actually, because especially in footwear mold, there are the designs comes at a lot of in the way of complexity. So when you work out on your CNC design, sometimes it will really take a lot of time in developing kind of a shapes exactly what you need for that one. And when you work out for kind of a redesign, so these 3D printed shoe molds really helps you in helping you out actually, how you can able to make these custom shapes and make much more in the way of easier time for you. And here, these materials can also withstand to a temperature for very heat application. That is what actually these advanced materials, not only just making for prototyping. Now you can able to try for all your manufacturing applications and also get as beauteous part as well how you are able to get it from your traditional parts. So talking about right now, prototyping, one thing I'm talking about something in tooling. So what is happening in an end product? So using technology like what I was talking about, like P3 kind of a technology, some of your low volume parts directly you can start using for this kind of an end application, like something like kind of an housings, enclosures, and some of the mold inserts actually you can also work out on that one. And there are some specific biocompatible materials. Even right now, when people are working on ventilators and people working on some custom shape everything into that one, there are already certified materials available for these kind of medical components, everything into that one. So like I can give you an overview right now. So this 3D printing technology, right now, people try to take it for their manufacturing innovation, not only just limited into that one. So you can make your time as close as possible and also make a lot of cost saving, and you can avoid your design mistakes at the very early stage, and you can able to invent your product at as close to the market at the fixed time. You can bring much more focused in the area to release this product. So with this, I can give who we are actually. So we are the statuses actually. We are the leader in this 3D printing technology into that one. And we have been having all the range of product portfolio, whatever I'm talking about it. That one. We have all these systems about from Polyget, Lithography, FDM, P3, programmable photopolymerization, and also SAP technology. And since as a world leader, we also have globally 20,000 plus customers. You can name from all the bigger brand names. They are all our customers. Thank you, team, and thanks everyone.
Thank you, Satish ji, for such a wonderful presentation. I think you have covered everything. So now I call upon our next speaker, Mr. Fred Fisher. I would like to introduce him. Fred is the Director of Products, Applications and Technology at Stratasys AP Limited, Hong Kong, overseeing applications, engineering, product management, and market development in South Asia region. With more than 20 years experience in additive manufacturing industry, Fred has led global initiatives in application, training, education, and channel partner enablement, promoting various 3D printing solutions and contributing to the development of new applications across different segments worldwide and in Asia. Fred has served in different roles at Stratasys, both in USA and in Asia, including applications and materials product director, business development director, sales channel manager, marketing manager, and product manager, making him an all-rounded 3D printing solutions expert. And now call upon Mr. Fred to share his expertise. Thank you.
All right. Well, thank you so much for the introduction. And again, very much a pleasure to be here. I always look forward to and really enjoy these events to help share kind of my and I think also Satish's passion of 3D printing and more importantly, how it can help your respective businesses and customers. So I was asked to put together some information around the toy and packaging based application. So we'll walk through that and also take kind of a look around, generally speaking, how 3D printing is applied in the plastics processing industry from my perspective. I've got a number of videos, so I'll ask if you can hear them. I know I got a lot of guidance as to how to share those. So just want to get some feedback. Maybe Satish, if you can let me know if you can hear them when we get to a video. So again, as you heard Satish talk about, kind of the primary reasons 3D printing is adopted in plastics processing, toys, and packaging are certainly no exceptions, are really around bringing better products to market, faster, better, and cheaper. And we see that play out across almost all industries adopting 3D printing, right? It doesn't matter if it's in automotive and mobility to anything around the consumer products and packaging, and certainly toys and the packaging industry, which we'll touch upon in a moment. So now I wanted to pull a few data points out, and this is a success story that we'll show in just a moment. This is a guy named Matt Lavin from a company called Togus in the US, a very classic plastics processing company, in his case based in the US, but the benefits and kind of where he applied 3D printing and why he applied 3D printing in his business is, I think, really relevant to, or maybe really relevant to this particular audience. So again, classic guy doing blow molding, injection molding, thermoforming, basic classic plastic processing. So where does 3D printing fit for a classic plastics processor? It's a few different things to kind of keep in mind. Now, first and foremost,
Fred, the audio is not coming.
No, no audio. You cannot hear the audio, Satish?
No audio yet.
Okay. One more time. Okay. All right. So I'll pull the video up while I do this, and again, you'll hear, or hopefully you'll hear anyway, him talk about why he invested in 3D printing. But one of the key things for him is about really differentiating his business amongst his peers, and also being able to deploy 3D printing on his manufacturing floor, also for kind of conventional methods as well. So we'll pull this up. And I think it's just a great story that talks about why he invested.
Fred, please go on screen sharing mode.
Yeah, no, I need to pull the video up. I'm just digging for the video right now, so no problem. All right. There we go. Okay. All right, it's coming. 1 second. I will share the screen. Okay, bear with me. Okay, we'll try this, and just interrupt me right away if it doesn't work.
No audio. Oh, you can walk through it.
Okay, all right. Well, I'll fast forward then to the information that you're looking for. All right. So anyways, Togus, why did they invest? Again, it's helped them differentiate themselves amongst their peers and to offer, again, a broader solution to their customers. It helped them diversify their revenue stream. So if you listen to him, he'll say that, kind of seems like when prototyping is up and manufacturing is down, and manufacturing is up and prototyping is down. So it kind of levels out the revenue stream. And he's also a really big adopter for putting additive out on the manufacturing floor. I may just go back, even though you can't hear the video, I'll just show the video. He puts it on his manufacturing floor, right? So again, this is a prototyping center. And what he does is he also deploys out on his manufacturing floor for 5S, jigs and fixtures, for tools to help his manufacturing. So here's a 3D printed end of arm tool. There's some 5S organizers for punches for CNC equipment. You see the 5S organizers in his drawers inside of the cabinet as well, right? So not just printing parts to deliver to his customers, both as prototypes, but also as production parts, but also as a mechanism to make his manufacturing organization run more smoothly. He's really on the edge of 5S, Six Sigma, innovation, etc. So a bit about why they adopted. Now, transitioning from kind of general plastics processing and talking about consumer goods specifically, this is very much a big driver for 3D printing. And especially because consumer products, are the visual appeal, and as many of you probably understand, why people choose one soft drink or one bottle of water over another, or one, in this case, nail polish over another, has a lot to do with how appealing the product is as it sits on the shelf. So the design of the packaging is critically important. So packaging has historically been one of the largest industries for prototyping, but you'll also see for some of the plastics processing applications as well, right? So it fits really across the entire spectrum, from prototyping to low volume manufacturing for plastics processing. So I'll start with tooling, because it's probably what more of you are interested in understand, and you'll see some of the same things, not accidentally, but very intentionally, as to what Satish referenced earlier. So thermoforming molds being one of those applications, actually incidentally as a design I made some time ago, as a little small prototype of a gum package, right, or the kind of a pill package for a gum package. Injection molding, right? Again, here, as Satish mentioned, generally speaking, both for thermoforming, but also especially for injection molding, it's where the volumes are relatively low and the materials are, let's say, in the kind of engineering to standard range, and also blow molding, right? So that's similar to the video that Satish referenced earlier. So again, where it fits, it's not a replacement for your long-term, high-quality conventional tooling across any of these, and for that matter, almost all the other application spectrums. It's a great fit when the requirements are low to moderate, right, from a volume of parts that are required standpoint, and there's really a pressure to get something to the end customer itself, the end customer, excuse me, and that's true again across all of these. So this is a key place. Now, as I referenced before, the packaging industry, the manufacturers, right, the people making the packaging items are also common adopters on their manufacturing floor for many of the same things that Satish referenced before. So custom equipment for the manufacturing, custom components, excuse me, for the manufacturing equipment, right? So whether it's a, to adapt the manufacturing equipment for the size bottle or the package that's being filled or moved through the organization, 3D printing is a great fit in many instances because the requirements, there's no real major aesthetic requirements there. You just need to make a tool or a part or a component for the manufacturing equipment that you can deploy on the floor very, very quickly. Also around moving and handling custom components, right? So jigs and fixtures, inspection fixtures, just general movement pallets, dunnage trays, either directly or indirectly produced, are really common places where 3D printing is used for the packaging industry, again, for the people manufacturing the packages themselves. And then also, as you saw in the, or I guess heard, excuse me, in the Togus video around the 5S organization, jigs, fixtures, just general tools and items out on the manufacturing floor to make it run better. And generally speaking, the term that we use is it enables manufacturers to put more on the floor, more tools, more components, more specialty products, more jigs, more fixtures on the floor to make the operation run smoothly. Where 3D printing fits in comparison to making those components conventionally is, where the complexity of the design or the part may need to be or can help the function if it's more complex in shape. Again, simple blocky shapes, like we just have a block with a couple holes in it, 3D printing is probably not your solution. But if you have a really organic shaped product, like many of the things that you see, or especially the window alignment fixture that you see over here, that's where 3D printing can really come to play, or where lightweighting is helpful, and or where it's a replacement for aging equipment, right? Something breaks, it's a 50-year-old piece of equipment, you need to make it yourself. You don't ring up the manufacturer to get it anymore. And again, the same benefits apply here around time, cost, in-house, and actually making a better product, in this instance, a better tool or a manufacturing component. So this is, I'll say, the production of the actual packaging equipment itself. Now, we also see many customers deploy it out on the floor to keep their equipment running well. Now, in this instance, it's a CNC shop, but they put, in this case, some inexpensive 3D printers in their shop to make components, right? Components to hold the product as it gets machined in their inspection area, etc. Right? So I'll show the video. I'll show the video, but I'll talk to the video itself and just kind of tell you what's happening in the video, right? So here, again, you see a really affordable, in this instance, an affordable FDM 3D printer out in the manufacturing floor that keeps these multi-million-dollar printers running really smoothly. And again, the items they're making, you see some of this that organizes the components on the manufacturing floor, the tooling heads, etc. on the manufacturing floor. It's a great way to drive efficiency in their organization. This is some of the inspection equipment that they do. So the end of arm tools to move parts in and out of the CNC equipment. And again, we see the same thing happen in injection molding, blow molding, etc. Something that goes in, grabs the product, and pulls it out of the equipment. So now more to kind of, I'll say, the visually appealing place where 3D printing is used in packaging. And this is really around starting to use 3D printing to explore more designs and bring a better product to market. As we mentioned before, there's an increasing focus on the customer experience that starts with the unboxing experience. And this is a classic example of an electronics manufacturer that was really looking to do that. How can they pack all of these things into the actual package itself, and how does the user feel as they open one design versus another, exploring color. So you can, of course, do this, through kind of a conventionally printed 3D printed part that's, all monotone, a white part, and then someone paints the model afterward, still in use today, or wraps it with a vinyl. What you see here are all examples that have been printed with full color 3D printers, so it can go from the digital design to what you see on the screen here directly from the 3D printer. Right, so of course that enables more iterations, more kind of a design exploration, and inevitably getting a better product to market faster. Okay. Now that plays out in many different places, right? So pulling, looking at the aesthetics, the visual appeal of a product earlier in the design cycle, of course, helps. It helps everyone bring a better product to market, right? So marketing models are kind of classic places. In this instance, this was a marketing model that was produced just for the photographer to set everything right prior to the actual production packaging being available. Quick prototyping of complex designs. This, again, the color 3D printers are enabling that to happen much better than it did before, and really then to enable data-driven decisions. So having focus groups that look at 5, 10 different design iterations and getting the data back to see what was visually appealing, both aesthetically appealing, but also what felt right. So the sound that a product makes when you open a package up, the feel of the product in your hand, those are things that are very, very difficult to derive from looking at a bunch of flat 2D printed images on a wall, rather than physically putting that part in the hand that not only has the feel and the sound as something opens and closes, but of course also the aesthetics itself, right? So that's a key way that 3D printing is used in the packaging industry. Just to give kind of a comparison around time, right? We talked many times around how time is a big benefit. Here you can see the benefit, or sorry, the typical time that it takes. So generally speaking, 3D printers will produce a part same day or next day. There is a correlation between the size of the part, the number of the parts that you're producing, and of course the technology that you choose, as Satish showed you. But generally speaking, 3D printers are not instantaneous, as probably most of you know. But if you put a design in, you'll probably get it same or next day, right? And this is an example of the beer bottles that you see on the screen here. Getting one, you get basically in basically the same business day, and as you pack many more in, you get those in a kind of a scaled fashion. There are economies of scales to pack many parts together. Now, in comparison to conventional outsourcing, this happens to be drawn in hours, right? So, but nevertheless, the point is doing this 3D printing in-house directly without having to polish, or without having to paint the models afterward, is a big time saver for many, many companies. And of course, that's a huge driver in the packaging industry, is that appeal of the product itself. So I'll just show kind of some of the video from a company called Kinetic Design, and just talk to the actual video itself, what's happening, right? So here they talk about how critically important product packaging design is, how they conventionally would go through those design concepts and iterations with their customers by looking at, again, a wall of concepts, two-dimensionally printed. And they still do this, but now as the product matures and as they have clients, they start to do that in physical three-dimensional form as well. So exploring various different shapes, different colors, opaque versus translucent materials directly from the 3D printer. So there's an example of what conventionally they would get from 3D printing, kind of a single white part that has the right shape and feel. But then the image that you see there, that's an example of a directly 3D printed part from a full color 3D printer. So again, for them, it really is critical. There's a spot in the video where actually they open a lipstick case, and the lipstick case itself pops You can actually hear the sound that it makes. And that was one of the key things that they wanted to assess in the design. Much like automotive companies, really obsess over what is the noise that the door makes as you close it, or the sound that a knob makes as you turn it, or the shifter, right? These are things that are really important to the customer experience, and 3D printing these days actually can enable, or some technologies can enable, that level of detailed assessment to happen. So quickly transitioning then into how 3D printing is used in the toy market. Here, very much a similar place, right, where exploration of a lot of different ideas from a prototyping standpoint, but out on the manufacturing floor, you absolutely see examples of 3D printing in all the examples that I just referenced earlier. Jigs, fixtures, organization tools, just stuff to make the manufacturing process run more efficiently. Now, this is an example of a company that's based here in Hong Kong. They design and actually then help create the or execute production of toys for countless different manufacturers. Mattel, Hasbro, Fisher Price, amongst many. This Nico is the one that they feature here, and I'll run the video and just kind of talk to it in the background around how how they've used 3D printing, right? So for them, it's a really key tool for much of the same benefits or reasons in terms of them engaging with their clients and customers. There's no better way to understand and feel how a toy will feel in the hands of a child, or how appealing it will look on the shelf, than three-dimensionally printing it, putting it in the hands of either the child and doing focus groups, or looking at a bunch of different designs, including the packaging, with the product up on the shelf to see what is appealing, right? So toys are certainly driven by many of the same different attributes. So just a couple other places, there are many different places that toys, it's sort of a derivative of toys, but we see the figurines, so Iron Man with someone's head on the actual model itself, or actually producing figurines for particular individuals. The gaming industry, the image that you see on the far right-hand side, this is an example of someone's character from the gaming industry as an example, right? So this is really a big driver for 3D printing. The figurine industry is growing very, very quickly. This happens to be my kids, right? So I had them 3D scanned about 2 months ago. The process took a matter of minutes to 3D scan them, and then we 3D printed them. This is actually the gift we gave my parents for Christmas, as an example. But the figurine industry is sort of a derivative of the toy industry that's growing really, really quickly. So kind of in summary, where's the 3D printing industry used both in packaging and the toy industry is, again, all in the same applications. Prototyping still is the core reason most customers adopt 3D printing today, but absolutely you see examples of tooling on almost all toy, almost all packaging OEMs floors. And there are increasing uses for low volume or custom manufacturing as it goes. Example, packaging, L'Oreal as an example, as well as Maybelline, are working to make, or actually are now producing custom packages to their very, very high-end clients that are unique to them, right? So not just the lipstick color, but the actual package itself is customized to the person, right? So just an example where 3D printing is going. So I'll pause there if there's questions, but that's kind of a little click deeper in terms of where 3D printing is used in both the packaging as well as the toy industry. No, you guys hear me?
Yeah, Fred, you're through?
Yeah.
Yeah, thank you very much, Fred. I could not get your last sentence, so it was real enlightening session from both of you. Got to learn many things, like what We started with 4 C's, what Satish told: compression of time, creativity, cost, and confidentiality. Yeah, all this really matter in the new product development cycle. Also, the range of material what Stratasys offers, that also is a huge, like right from ABS to PC, nylon, PEEK and Ultem, which I think no other technology offers. So a customer can have a variety of materials which they can choose from for making their prototypes. So I think we take on questions. To start with, the first question is, how do you see 3D printing applied in mass manufacturing, and what will be the cost impact vis-a-vis the traditional process?
Sure. Yes. So listen, maybe Satish will both tag team on these, but long story short, mass manufacturing, right? So if you look at where 3D printing fits, again, the age-old story is, generally where the volumes are low and the complexity or the value of the product is high. Give an example. Almost all of the high performance vehicles, so Ferrari, Lamborghini, Aston Martin, you name it, they all have 3D printed components in their vehicle to really push the performance edge. Conversely, very few, let's say the Toyota Camry, right? The Ford Escort, some of these high volume, relatively affordable vehicles, there's very few or even no directly printed 3D parts in it. Now, that is changing, right? Some of the technologies that Satish mentioned, so the powder bed fusion-based technologies, the DLP and the VAT-based technologies, these are really pushing the envelope in terms of the quantity of parts where 3D printing makes economical sense. So, but as it relates to making, extremely commodity widgets, I'll give an example. The bottle cap, this bottle cap that I have here for an order PET bottle, I it's probably very unlikely that 3D printing, at least for these future, would be a logical solution to the I don't know, probably millions of these bottle caps that are, but an end of arm tool to move it from the mold into the bin, a fixture to scan article as an example. These are places where 3D printing is used indirectly in mass manufacturing, for to help make it right the actual production itself. So long story short, 3D printing still used in relative and value products, but that line has moved and continues to move as technologies progress.
Thank you. We move on to the second question. As you are talking about automotive, we have one question regarding to EV. How do you see the potential for 3D printing in EV sector, and what is the economical viability in this sector?
Sure. Yeah. So EV, almost every OEM that we're engaged with, and we're embedded with just about every OEM, EVs are a really big push, right? They're trying to innovate their products again to make the vehicle distance further, to drive the efficiency up, the speed of the charging, and so forth. So it's a huge innovation push for the automotive companies and OEMs and suppliers. And 3D printing is helping them in a few ways. Number one, to figure out in the actual vehicle itself, how do they pack more battery into the vehicle itself, right? To drive more distance and do that in innovative ways, right? How can they make the floor pan design to put more capacity in the actual vehicle itself? Secondly, is absolutely around the tooling, right? So how do they make the product more efficiently for all the applications that Satish referenced? And in some instances, actually, no, I shouldn't say something. In many instances, they're also doing a lot of pilot production, right? The first 10, 100 vehicles to go put it on the road, get data back from those vehicles, and then move to conventional manufacturing. Tesla, as an example, massive adopter of 3D printers for exactly the reasons, and amongst others, certainly amongst those three.
Thank you.
I would like to add a point specific to that one in EV segment, actually, even in automotive. So some of the plastics like ESD requirement will be there, some of the requirements will be there. And for that, you don't need to go for a separate manufacturing process, because like electrostatic dissipative, this is actually kind of a property which has already been aligned with kind of our technology. You can directly use those things in the part of the process. And some of the area where you need to go for an extreme high temperature, like especially with Fred mentioning, the battery, wherever you want to kind of a closure where high temperature is supposed to maintain, and also it needs to be an lightweight, because that increases your vehicle kind of payload capacity more. So you can able to take some of the advanced materials and the FST materials for such applications. So this really helps them, because you can also meet the standards and also help you in go for your certification easily, and also pass your test, everything much faster in that way.
Yeah, Satish, thank you for this introducing of this new material ESD. Looks very promising. So in that regard, I would like to know what new materials we should be expecting in the years to come. What different materials we are expecting.
So sure, I'll give my kind of a commentary, and Satish, please add to it. So generally speaking, 3D printing is moving from generalization to, specialization. Now, so ESD to some extent is an example of that, right? All electrostatic sensitive applications. You could call that a bit of a specialty, but certainly in the medical space, etc. We see, some of the high performance industries really driving a demand for high performance materials. If you look at some of the metals industry, the thermoplastics materials that have come out, and even the polymers applications are really trying to do a few things. Number one, push the application spectrum outward. Aerospace and performance automotive and defense are probably three of the largest industries. You can maybe argue space as well as a fourth, really pushing the envelope on this. EV actually is a derivative of that, right? A derivative of that kind of a specialty application, where they're again trying to push more exotic capabilities, the output of the part via material innovation. Many companies, Stratasys included, kind of realize this, and we're not the only ones, and are moving to more of a hybrid model. Not just our materials we've developed and we've the printer internally to are available in our products, but we're moving to a hybrid model where other OEM suppliers or customers who have a really disruptive need themselves can take and tune the printer to their particular material. This to even further drive an inflection point of materials out there. So, but long story short, it will be around higher performance, specifically around aerospace, the space industry. I'll say automotive, maybe a bit of the performance automotive, and then also a handful of the specialty different applications. Those are really the big drivers. The big drivers.
Maybe on to next question. Satish was showing an example of footwear mold. So what would be the typical life of this mold, and what type of materials can be injected into it?
Yeah, very good question actually. So primarily these molds actually, like we have shown about a lot of different kind of molding, from injection mold, silicon mold, and also from blow molding. So primarily I assume this question is from injection mold. If that is the case, I assume most viscous material, actually low viscous material is the best choice actually. For actually you can take a volume of even close to 500 to 1000 is a good number. And obviously the viscosity, the way it is increasing, the volume reduces. And like we mentioned, this mold is not a replacement for your existing steel mold. These molds are made in such a way like that you can squeeze your development time to almost 60% even that way. so that you can immediately get your actual protoparts out of it. So polyethylene, polypropylene. So these are some of the best materials I would suggest to go with immediately in that side actually. And we have already have some application guide how to select for these materials also in our list. We have about that one. And generally, material which can able to go to a melting temperature of close to 300 degrees Celsius is a best fit. Max.
Okay. Talking about this injection and blow mold, how is the heat dissipation being taken care of? Because all these materials, if you are injecting, so there is a lot of heat involved, and if you have to produce maybe 500,000 numbers, so like a metal mold, how the heat dissipation is taken care of in these molds?
Yeah, so generally we used to make some cooling lines in the part of that molding. Actually, you can able to do some conformal cooling. If compared to your traditional process, you can able to do some conformal cooling. So that is one of the biggest advantage you can do into that one. And immediately we also suggest something in the process parameter also, because you cannot use the same process settings what you use it for your traditional mold setting. You need to do some small tweak actually to work for this one, because obviously this is a plastic, though it can able to take some impact load. We need to consider in those aspects. So that is how we will work out on that way in getting the numbers and also working out on the part for traditional requirements of the materials.
Thank you. Finally, the last question: what do you see the future of additive manufacturing in the Indian scope of applications?
I would like to add a few things, and I would like to add a Fred to add more points along with that one. See, right now, industry, we call it as an additive 2.0, because 3D printing is not new to many of them. Actually, people want to go. But what happened now, industry is moving to the next stage. People want to more on manufacturing floor readiness. Actually, people want to go with industry 4.0, and there are a lot of innovations comes in the way of expanding in the choice of material. So that is the reason Stratasys come through with open choice of material. We are collaborating with world's best manufacturers from like Henkel, BASF, Covestro, and all biggest brand names into that one. So whatever those high performance materials from that one, you can directly start use those materials in that way and simplify those processes for your own specific requirements. Because rather than mass manufacturing, mass customization is the next stage right now people going into that one. And for such mass customization, people should have a smart machine with respect to kind of an advanced materials and easy workflow. So we should select a machine or kind of a technology that should meet all these requirements to go to the next stage of production. Fred, you can add more points along with me. I can feel from this side.
Again, the Indian market, I think, very much both follows and leads the industry in adoption, right? So again, we see increased pushes into manufacturing, as Satish mentioned, right, in these specialty use cases and applications. Again, you know, where the economic or technological barriers of conventional methods become a barrier to whether it's prototyping, manufacturing, etc. This is where 3D printing comes in. So, and a lot of this starts in the education industry. So ensuring that, you know, next generation industrial designers, mechanical engineers, tooling engineers, manufacturing engineers, you know, understand not just as Satish mentioned, the 3D print 1.0 wave, but additive manufacturing 2.0, where it's being applied today. So, you know, really look forward to that continuing to happen. So again, big pushes in all things advanced applications.
Yeah. Thank you very much, Fred and Satish. It was really a lot of inputs for the participants in the field of 3D printing, and the way 3D printing looks like today. We call it as the new disruptive technology for manufacturing, and I look forward that more and more people adopt this technology in India. And now I hand over my stage to Mr. Ajay Desai, who will carry on the session ahead. Mr. Ajay Desai, please. Ajay, you are on mute.
I'm sorry. Good evening to one and all. 3D printing today has begun to open new doors. One can help reduce days of production cycles, remove complexity from final assembly, produce lightweight, high strength structures, create hyper realistic prototypes, and be more competitive. I think after a wonderful presentation by Mr. Fred and Shidhar, it gives me immense pleasure to deliver the vote of thanks for this event. I would like to thank our distinguished speaker, Mr. Satish Kumar, Senior Application Specialist for Statistics and for the Southeast Asia market, and Mr. Fred Fisher, Director of Products, Application and Technology at Statistics AP Limited, for their insight into the 3D printing technologies used in the plastic industry applications, for guiding us through the journey of 3D printing. I want to thank Mr. Kishore Sampat, President AIPMA, and Mr. Arvind Mehta, Chairman AIPMA MTech, for their contribution to MTech, and Mr. Paresh Beda for ably moderating at this meeting today. Last but not the least, I express to our wonderful audience who have turned out in such large numbers and would go home with more knowledge at the end of their today's presentation. Thank you.
Thank you, Panji.
So I would thank finally once again to all our people for having spent their time, and Mr. Caesar and Mr. Fred for their wonderful presentation. Thank you very much. We look forward, and our partnering together will bring us to our industry to a better height. Thank you.
Thank you, everyone. Have a great afternoon and a great weekend.
Thank you, everyone. Take care. Bye.